Welcome to lesson 17, Heaps. These are tree-like structures that work like priority queues. 1. They're always full from left to right except for the last row that may be incomplete. 2. Each node is always larger than its children. 3. Usually implemented as an array. As they are weakly sorted, orderly traversing the nodes is difficult, hence looking for a specific key is not easy. However, these structures allow for fast removal of the maximum node and quick insertion of the new ones. To remove a node, the following procedure will have to be implemented. 1. Remove the root. 2. Move the last node into the root position. 3. Push the rightmost node in the lowest occupied level down until it is located below a larger one and above a smaller one. Insertion will place the new node in the first open position and then will push it up until it is located above a smaller value and below a greater one. Let's have a look at some of the differences between heaps and trees. Those are going to become very clear after you have a look at the practical example. So heaps can be implemented using arrays while trees cannot. And let's see why. Heap operations only need bubble up or bubble down a single tree branch, while a tree will require complex rotations, which would have the whole array rotating. So, implementing heaps is easier as they do not need pointers to left, right, and parent nodes. Let's build the application. Let's run it. Okay, 10 will be enough. Random values. So we can populate the array. Okay, it is full, sure. So, as you can see, it looks like a tree, but it's definitely not a tree. In fact, if you move right, children are smaller than their parents, which wouldn't happen in a normal tree. Also, as you can see, each parent is bigger than its children, which is definitely not a case in a normal tree. Let's try to remove an item. Okay, so 100 is gone. Insert. Okay, so 90 is still here. Change. Okay. 89 was promoted, right? We can go through the code now. So we have a class node, which is going to be storing values. And then the class heap, which will have an array of nodes. And then nodenum to keep track of the number of items that get inserted. Then we have a constructor. And then is empty, is full, and insert node. So you insert physically a node into the array. And then you call bubble up. Okay, bubble up, create a pointer at the next free slot. So just bear in mind here the way we're calling the method is nodenum++. Each cycle grabs the parent node and continues while root is not reached, and the parent node key is smaller than the key of the new node. That is the condition. This over here means that you are dividing this by 2, right? So move the parent down, move the index up. So you're swapping the two nodes. Restore the node that was saved at the beginning. Bubble down, which is used by remove and change methods. If this is called by remove, then the index is root. back up the index, and then you have this while over here, which will run until there is at least a child. Now, here you are having node num divided by 2, while index multiplied by 2. Check if a right child exists. So check if there is at least a next node, and then you check the key. Now, this will run if there is a right child, while you're gonna have bigger child equal to left child if there is no right child. If the initial node key is bigger than this one, the job is done. Break and you exit the cycle. Otherwise, move the node and go down. And then you restore the root to index. Remove node. So you grab the root, you remove root and bubble up the last node to root. As we've seen before, this means that you push the rightmost node in the lowest occupied level down until it is located below a larger node and above a smaller one. And then you return the old root. And change. So you check if you are working out the boundaries of the array. You back up the old value. You change the value. Then you move the new value up if bigger than the previous one. Otherwise, you move it down. And then you return true. So, hope you've enjoyed this class. Thank you very much for watching.